Even when you're using a theodolite over long distance, it's not the problem that the crosshair is changing. It's the problem that the objects in the distance are changing in reference to the horizontal crosshairs. I don't think that's the point y'all don't get.
Well, I think this is the point that Bedford Level proved to be wrong. That's the same principle he used to show that the Earth isn't flat. Is he had those 3 poles or whatever, and saw that they were not, even though that they were the same height and that they were level as far as the water, they weren't the same horizontal.
Yeah, how much refraction and perspective, however you want to say it, angular
That
size
didn't
change
matter. That didn't matter.
It was
The
yeah, they did. Yeah, it does.
No, it was the height at which the pole sat that was the difference.
It's not
from your tangent point. That's it. That's all there is to it. Because you could do it without you could do it just by measuring everything. No optics.
So are you the one yesterday that said over a mile my midpoint would be 2 inches higher if it was water?
I didn't even speak to you yesterday.
Okay, so it wasn't you. Do you agree with that?
I don't know what the context is.
Talking about, but yeah, there's a yeah.
We had a mile horizontal. The midpoint at a half a mile, you filled it that horizontal tank or whatever.
Position, you're measuring it to be level with the further position. If you did this, then yeah, in the center, if those 2 distances were a mile, then that one in the center, there'd be a 2-inch difference. But in neither of those positions did you make a horizontal plane, because you made them level to each other. So when I say horizontal, I'm strictly speaking about perpendicular to the vertical.
Kosha, who are you talking to?
I was talking to Davros and Rakia.
Yeah.
I can't hear him. All right, thank you.
Sorry, when I get a phone call, it cuts me out of Discord for some reason. They dumped 4 yards of concrete on the road somewhere. One of the concrete companies was calling me, trying to get my bobcat over.
Can I ask you a question real quick, Rakia?
Mm-hmm.
So let's say you set up a theodolite and you were trying to measure the horizontal angle between 2 targets in the distance, right? You with me so far?
Yeah.
All right, so the angle that I measure according to the theodolite is 15 degrees, right? How much should I adjust that number due to perspective before I write it down?
I don't know.
Nothing, right? I don't need to adjust it for perspective
I would say
at all, do I?
Over what distance?
Thank you.
I would say no. Yeah.
Thank you very much, sir.
No problem, sir. What distance are you looking through a theodolite with?
Either 10 million miles or 2 feet, one of those two.
You don't adjust the value for perspective, but if you don't take it into account and know that object is in a different place due to the atmosphere, then you're getting the wrong measurement.
But we were talking about
perspective. What's the value of perspective?
Okay,
What's the value of perspective?
I already answered the perspective part.
So you can
What's the
quit
value?
saying you need to take perspective into account, right?
When you're viewing things, yes.
Thank you.
Not when you're measuring. But you don't measure things at that distance because of those problems.
So a theodolite doesn't let you. It's not like other lenses or scopes where you can.
You can adjust, yeah.
Move the position of your eye and have the background image shift. It's too tight, basically.
You can manually adjust the crosshairs in certain systems, and there's different reasons why you would do that. All of them are optical.
Right.
And there's manuals for that. I'm not as familiar with that because I don't, I'm not in that business. I never have said I was, but I know about it. but I know they don't do it for accuracy. You're never going to measure, like, to get how level a building is from 20 miles away or whatever. You know, you're never going to measure from 20 miles away and say, you know, that building is 30 feet off the ground, because they know it would not be accurate. Hugely off, like multiple feet, depending on the day.
Right. Well, the phenomenon I guess I'm trying to term here is what is the simple parallax, right? Like, right? Like that's perspective, right? If you were to, you know, move your eye side to side, right, Phil Ko?
No.
What?
I don't think he's going to agree with that either. I'm not sure if I do.
Well, you could do it with like a toilet paper roll. You know what I'm saying? But you have a middle point there. I'm asking, are theodolites set up to where they eliminate that variable, basically?
It can't eliminate the phenomena, but it can put that crosshair in a certain position every time. But that position over long distance is not correct. It's not accurate.
Yeah, and what do you mean by parallax? What the fuck does a parallax measurement have to do with looking across the ground?
Well, he said that Phil was asking, are you going to have to adjust your angle, right? And if your target is off, I guess I'm asking, your eye's right up into the theodolite, you're not going to be able to create parallax, right?
But you're only taking one measurement. You need at least two for parallax.
There is no parallax. There's no movement of the crosshair against the scene you are trying to view.
Right.
Yeah, there are other phenomena though where the water appears to be trickling or moving. That causes optical illusions. There's all types of shadowing. When you're looking through a tube, you know, like a telescope or anything, a point sight, that causes some optical illusions. I mean, there's all types of things. Your surroundings, whether you're looking through like a corridor, like down a road, you have trees on both sides of the road. But when you set your theodolite up on that road and it's plumb and you create that horizontal is correct. You can transfer that horizontal as far as you want to go and measure drop from it or whatever, and that will give you accurate measurements. But when you do it over distance, it gets screwed up. I mean, it's never done.
Yes, it is done. It is done.
It's done for certain reasons, but not for
drop from horizontal is only relevant to your point of the theodolite, not anywhere else along that line.
Okay.
These measurements are made at long distance when cartographers survey mountain and hilltops.
They're measuring angles, they're measuring slopes and the angles, not measuring drop from anything. What are you talking about, man?
Well, if there's any refraction from the atmosphere, it will affect those readings as well. But as we've just seen with this process, that the surveyors that went across the North America showed, you can account for that refraction at these extreme distances and reduce it to negligible amounts.
Yeah, I mean, I can say it over and over again. When you do it over land, you're measuring slope, right? The topography.
No.
Up and down. Yeah.
No, when you are measuring hilltop to hilltop.
Yeah. Like I said, that's different. That's not measuring drop from horizontal.
Doesn't matter what it is, the refraction can be accounted for.
Yeah, and get pretty close to damn near accurate for that account. But when you're needing to be very accurate for slope or for drop from horizontal, when you're measuring a mile and trying to measure 8 inches over water, you don't get it.
Yeah, but you don't need to measure over water, right? You can measure from two mountaintops and measure spherical excess. That's greater than 180 degrees every single time. And then you can use that to tabulate the R value, and the R value is exactly the same as if you measured the drop from any elevation.
Calculate it, right? Yeah, go ahead. I'm fine with that. That's what y'all do. That's how you get your
We were talking about
out
land observations. I don't know why it's been moved to the ocean.
Yeah, there's no reason to do that.
Because the ocean, we know I'm not moving it to the ocean. I'm moving it over undisturbed water, static water. When you do it over static water, you don't get that slope or angle change or drop from horizontal, whatever the hell y'all want to call it.
Which
don't get it.
which body of water are you calling static?
Any body of water that doesn't have you know, wind and tides and currents moving through it.
Okay, so something that's impossible.
Well, I would say it's impossible. I say water's always in motion, but it's not being affected to the extent that it would create an 8-inch curve over 1 mile.
Yeah, but there's
What does
places
the
like
motion?
You're
Like
trying to deflate the argument.
Lake Michigan is the same elevation on both sides, and then
And
you can't see the buildings most of the time.
and
So
why would you expect
so
to?
that's
Is
that's
there
an exact
atmosphere?
that's an exact
How far away is that?
contradiction what you just said.
Is there dust in that air?
Do we
How
know
about
what
water
8
particles?
inches at 1 mile is in as an angular deflection?
0.00000, but I know what 8 inches is.
That's what I asked. What is 8 inches over a mile as an angular deflection?
I don't know. You can
Isn't it almost an
calculate
arc?
it.
Yeah.
It's very, very small. Very small. You couldn't see it with the naked eye.
Oh, so
But
2
you
tenths
can
of
measure 8
fuck
inches
all
over
then.
one.
No,
You can
it's.
measure drop
But
horizontal.
what I'm asking
I
for is
promise
because
you
I
that.
want it as a comparison of the accuracies of theodolites.
Is it
You have
in
to
our arc
calculate it.
minute?
It's very small.
It would be in arc minutes, I suspect. Yeah.
It's less
Yeah.
than the accuracy of a theodolite. I would agree with that.
Actually, that
So
brings up my.
it's negligible then.
No, it's not negligible because when you do it very
If you said it
accurately,
was less than the error,
you
it's
don't get what I'm
negligible.
saying. You're just taking what I'm saying to make it fit your narrative.
What the fuck does that mean? Are you crazy? You just said that if
Take
it was
that 8 inch,
below
I tell
the
you what,
error,
take
if it's
that
below
8
the
inch,
error margin, it's negligible.
take a 8
That's what
inch
an error
stick,
margin's for.
take a 8 inch rod, a metal rod, and go walk a mile, and every step you take, hit yourself in the nose with that 8 inches and tell me it's not significant. 8 inches over 1 mile is easily measured. Easily.
We do.
But you said that it's negligible. Like you said that it's
No, that's
you
not
can't
what
measure
we were
it
talking about. Yes, you can measure it.
optically.
He's talking about oh my God.
So how about when they do measure it, like I posted this picture right there?
I'm supposed to tell you how I know something from a picture you posted.
Yeah, you said still body of water, you won't measure that 8 inches of drop. So what about when they do?
Hey, you're looking over half a mile. That's a half a mile, right?
No, it's more than a mile.
It's more than what?
7,311 feet.
Oh, that's more than a mile. That's a different one than what I'm used to. And how many inches did they get different?
They showed drop, that's it.
How much drop? I mean, shouldn't it match perfectly?
Why would it match
What?
perfectly?
Yeah, I know it won't.
How does it
Because
match?
you're looking through the atmosphere over a mile. It's not going to match. Now that horizontal line is right.
Yeah,
So
but
make
you
up your
said
mind. Can you measure drop or can't you measure drop?
Not over that distance. No, not at one shot.
Then why are we
So-
saying drop to the other theodolite?
Because that's an optical phenomenon. It's not physical.
What?
What the
It's
point
an
of this?
optical
Don't forget.
phenomenon.
That
Right.
crosshair is a physical position. That
I was gonna say
crosshair right
to
there.
you, Chef, go ahead.
Use that same tool to the limits that you can use it, which is about 300 foot. That day looks very clear due to that picture, unless they stacked it. So the colors are bright, everything's sharp. So you could probably use that instrument up to 300 foot on that day to great accuracy.
I can get a
you-
theodolite here that's accurate up to 2 kilometers.
Good luck with that. Go ahead.
Its error margins plus or minus 3 millimeters at 2 kilometers, which is nearly a mile and a half.
Okay, so you're willing to put your where would you put your head there if that crosshair was a scope?
Why are you changing the parameters?
I'm not. I told y'all for a year when y'all were coming up with these crosshairs on the side of a building and measuring how much of the building was missing. For a year and a half, I told y'all that wasn't right. told y'all, and I gave you the reasons why.
And then you
And
showed.
now y'all agree with me, but now y'all are still fighting.
But there's a difference. You showed George's picture with about 3 feet of refraction.
Okay. Over 2 miles.
So where's George's picture that shows 8,000 feet of refraction? And then you can throw away Mount Rainier.
George's picture is 2 miles, not 130 miles. So why are you trying to conflate?
Okay, so let's do some multiplication.
No, you can't do it that way. That's not the way it works. It's not a straight multiplier. No, you cannot.
All right, let's do it exponential then.
No, you can't. Because on different days, even at 2 miles, it's different. Because the atmosphere changes.
No. You're taking the measurements, not the optical.
You don't even understand the argument, man.
All right, so let's say
you don't know how to measure shit.
Well, I know how George has his theodolite set up. You're just an angry old man for some reason.
No, we're talking about measurements.
Yeah, we're talking about George setting up a very accurate measuring tool that creates a horizontal, and the objects in the distance over 2.7
Dave, straw man,
miles being 6.
I'm calling a straw man.
You can call whatever you want, angry old man.
You straw man.
Wait a minute. Which one of you guys is older?
The atmosphere changed, not his theodolite crosshairs. Nothing changed on his measuring tool. He set it up in the same position. He shot it in the same direction. It was plumb and level. It created a horizontal. The only thing that changed was the atmosphere.
So
the way the light is getting back to the viewer, which is that tool.
So Rocky, do you think anybody has measured refraction?
Yep.
Okay, so let's see.
All kind of useful charts for it.
All right, so let's say I went and found all the measurements of refraction I possibly could, and I looked for the most extreme refraction I could find, right? And then what if the amount I drop a C is 10 times as much as the worst refraction I could even find? Then what does that mean to you?
So what do those tables go up to? And where were they? How were they created? Were they created?
They measured
using your same parameters?
No, they go out, they set up 2 targets, reciprocal zenith angles, and they sit there and they watch it over different surfaces and different temperatures and different sunny days and cloudy days. And they watch and record what happens.
They take mean averages, maybe, something like that, and create an index.
They graph it out.
And then you use it in your observation, and you get a damn near close what the refraction is on that day. Hey,
no, I'm talking about...
Doesn't mean it's accurate.
I'm talking about something different. I'm just looking at all those measurements and seeing what's the worst possible refraction they ever saw in the whole experiment, right? And then I'm looking at 8,000 feet of Rainier missing, and I say, well, how much refraction would that take? And what's the worst amount of refraction any of them ever recorded?
Are you taking what's missing? Shouldn't you be taking the drop from the top of the mountain?
Well, how do you figure out drop?
You do it. It's your deal. You're saying how much is missing.
Okay, so
the bottom.
So I can't.
What would that matter? That's not curvature.
Why don't you think that would matter?
That's what's optically missing. That's not how much. No. That's not how much lower the mountain is due to your viewer height.
Well, here's
Are you gonna let someone respond?
Oh yeah, okay. Is that angry old man?
Okay, Kosho.
Can you look at the chat, Rocky? Can you look at the chat?
I'm looking at your mountain.
All right. So you see how they lined that, what they could see over the horizon up with the other one, right? So they know how much it reduced in angular size, right? So we're accounting for perspective. So we know how much it shrunk, but we also know how much of that mountain is missing. If the Earth was flat and there was no refraction, we'd see the whole mountain. There's no reason on a flat Earth we shouldn't see that entire mountain unless it's refraction, right? If the Earth is flat and there's no refraction, you'd see the whole mountain.
There's no refraction.
Yes, if there's no refraction, let's say we're in a magical world where there's no refraction and the Earth is flat, you'd see the whole mountain, correct?
You wouldn't.
Why not?
There's other stuff in the way.
What?
That tree line for one.
Okay, so how much of that tree line would you?
I don't know. You'd have to know all the angles. You'd have to know the distances. And
you can see it. You can see it right there. We see how big the mountain still is because we compared angular sizes. So we can see how much of that mountain is missing, and we can see how tall those trees are compared to how big the actual mountain is, and we can see it's only a tiny portion. Correct?
I don't get what you're saying.
So the only thing we can really...
not correct.
So what we can attribute... So we need to attribute all of this to refraction if the Earth is flat.
No.
So what would be the optical cord
That's
or
not
necessary
what
to
you just
produce
said
that
was
image?
false.
Okay, then correct me.
Well, how tall are those trees right there in front? Is the one that's further away taken at the same angle?
In the image, you can see how much of the trees are obstructing the mountains.
Well, that's why you can't see the bottom of the mountain right now, right? The angle is blocking the bottom because you're obviously close in
About
this
the mountain that
picture.
you can see.
Say 50 miles, maybe something like that.
So where's the rest of the mountain?
I don't even know what you're asking. You mean the bottom of it?
Yep. Where's the bottom 8,000 feet of that mountain?
It's obstructed.
By?
Whatever. Trees, other mountains, whatever's in the way. Atmosphere.
Oh, we can see that those trees only cover up a tiny
You're
portion
not
of the angular size of that
showing that.
mountain.
You're not showing that.
Okay, let me post you another
I've
picture. I'll
seen
post
all
the
your
originals
pictures.
for you.
And I've heard your explanations.
You realize
how the
he's
trees
just
don't matter.
hand waving all your
I'm not
evidence.
hand waving anything.
You are.
He's not telling me anything. He's not telling me any information.
If we're standing and looking at that view, though, and we zoom in, you're going to tell me for a fact, 1,000%, that we're not going to see anything but what we're seeing in that picture, and we're not going to see the bottom of that mountain or anything in the trees?
That's not
No,
true
you're
either.
not going to.
Bull
You won't
crap.
see it. You won't bring it back. You won't bring it back over the horizon. They did
Well,
it.
It's not.
Yeah.
Sorry.
What do you mean it's not sorry?
Well, you're
Like,
just claiming
how can you make that
refraction. Well, how
statement?
can you guys claim it's refraction?
Well, go and disprove it then. Go falsify it.
I'm not
Falsify your claim.
I'm not saying that I'm sorry, I'm not saying your words. I'm not saying refraction doesn't exist. What I'm saying is you can't claim what we're seeing is refraction. You have not proved that light can bend in that kind of
I'm
manner.
not claiming.
And until you prove that, you can't claim it's refraction.
Then why would you claim refraction then?
No, because refraction does exist. Okay.
Why would you claim it's refraction
But
if he
I'm not.
claim it's refraction?
I never said it was refraction. Why? I'm seeing.
No,
what
I
I'm
know.
seeing. You guys said that.
Right, you're seeing. Okay, so you're agreeing that you see the Earth obstruct the object without refraction.
No, I'm not saying that the Earth is
obstructing
anything.
Yeah.
I live in a flat plane. I'm not saying any of
But
that.
so you're saying we're seeing
you
what we're
guys are
seeing
claiming
is
what
an
we're
artifact of
seeing is refraction.
refraction, and it's actually flat though. That's what
I'm
you're saying.
trying to say is you guys are claiming it's refraction only, and that is your answer.
But that's what you're doing though. It's a projection
I'm
because
not.
if it's flat
not,
and we're seeing obstructed view, and it's because of refraction, then what is your
explanation? Atmospheric conditions, and it's called
that's refraction. Yeah, you're using literally refraction as your example.
Above the horizon.
Right, but you get what you're doing, right? You're saying that what we're seeing there, it must be atmospheric conditions, which is refraction, but we're not allowed to say that.
So
you guys are claiming,
you're projecting. I'm just listening for long enough.
Up in the air, and you're going to tell me that.
Does anyone else get what I'm trying to
say
say here?
I get what you're trying to say. You believe in optical illusions, don't you?
No, you're using that.
So you don't.
You're
So
saying it's an
King, you
optical
don't.
illusion.
No,
Yeah,
I'm
you're
saying everything is refracted always.
Cool. So
right then.
But
because
what she's
if I
saying
say
is
refraction
that,
doesn't
you're
exist,
you're
and you
saying
guys
it's
get pissed at that.
refraction
It's not
to the
refraction.
Globers, right? And then and the Globers are saying, well, it's a mixture between what we're seeing and refraction. And you're saying that it's only refraction.
No.
Because we're not seeing a hump. There's not a hump there. There's no globe there. It's flat. So what we're seeing is only refraction. Yet she's claiming that that's what we're saying is that we believe in only in refraction. Yet that's her doing that. She's farting and then pointing around at everybody else saying that you all farted.
What are you claiming? What? It's like Chicago. Why do I say Chicago skyline?
No. Get back to what he's talking about. It's the fact that we use refraction in part of our measurements, right? And then you guys hand wave it away when we say it's refraction that's causing something.
Let's listen. Phil, we know what the actual argument is. No one should even be making a claim about these pictures. He hasn't even explained it yet. He's just now posted the other picture and compared them and stuff. So.
Well, Coach, you know what I'm talking about. You know well too. You know, I'm not.
Yeah, I think that You spoke up too soon. I think you assumed maybe something else was being said about about these mountains. But when you see that the picture